Hello and welcome everyone to the second Pytest Fixture session with Brian Bouters. If you have any questions for Brian, please feel free to post them here on the YouTube live chat or ping me mcore in Pulp or Pulp Dev and I will get those questions to Brian. If you have any problems with the live stream, please let me know at any stage as well. And that is everything. So I think, Brian, in your own time, you can begin the second part of your session.
All right, thanks, Melanie, and welcome. We're going to dive right in. If this is the second, as Melanie said, the second session, so we're going to be picking up this slide deck in kind of the middle. Any questions are welcome. My goal, as I said last time, is to enable anyone to use this testing approach for Pulp. If a conversation about, why is something a certain way, or hey, I'm not quite sure how to apply this, like I've heard what you said, Brian, but I'm still not really sure, please come and talk to me because I would love to help. All right, so this section of the talk is really going to focus on the use of new Pytest fixtures that have been added to Pulp Smash, which can set up a web server to serve data to Pulp as it downloads that data. And my goal today is to mostly show you how to use them and not quite so much to talk about how they're built, but you can go look at them. And if you're interested in that too, we can certainly talk more about that. So as I said, these fixtures are already available in Pulp Smash, and Pulp Smash is included as a dependency for pretty much every Pulp plugin and Pulp core, and pretty much anything Pulp. When you go to test it, you're going to use Pulp Smash. And so you already have these things available. You don't have to go and turn them on. They're literally already in your repository because you're using Pulp Smash. So let's talk about how to use them since they're already available to you. To use the local fixture server, I'm going to talk through these 5 points, and then we're going to kind of go back through them and actually look at the examples. You want to add fixtures, data fixtures, to your repo. So a data fixture, for instance, for like Pulp file is it's a Pulp manifest file that contains the names of other files. These are primarily text files, and it's then it's got each of those text files has some other data in it, and this is what a Pulp file thing, the data that a Pulp file downloads looks like. So for RPM, it's going to look different. For other content types, it's going to look different from that. But you're going to want to put the fixture data in your local repo, and actually, I am going to just give the example here before we go on. So we've put the basic fixture, which is one of the data fixtures that's available on fixtures.pulpproject.org. So if you look on fixtures.pulpproject.org, you'll see a lot of fixtures out here. All of these are good candidates to be moved into individual repositories. And this file one here is has these 3 files and this Pulp manifest. So this is what I've called the basic fixture. Melanie, are you sharing?
Would you just increase the...
Oh, yeah, of course.
Thank you.
It's very helpful. Thank you so much. And also, let me do that here as well. So when we say move the fixture into your repository, for example, here in Pulp core, we've moved this basic fixture, which has the same files and this Pulp manifest, into here. And over time, as we add more data fixtures for other sorts of tests, this directory will grow. This is in a fixtures directory, which is in the tests area. So I expect that over time, we will have file chunked, file DL forward, reverse, etc. And eventually all of these things will be moved in. So that's kind of the first thing you want to do if you're going to have your, if you're going to serve data to Pulp, the system under test, using these new fixtures, you're going to want to have those fixtures actually stored with your repository, which is one of the primary goals of this work, because we want the fixtures to be versioned, put them in the repository, does that. We also want them to be able to be run locally and not involve the internet. And so having the fixture data there with the test code is key to doing that. So anyways, put the fixtures in your repository. That's the example. Then what you're going to do is you're going to define the root of the fixture server, and we'll look at that in a second. This defines what area of your repository's directory structure is where the fixtures come from. Then you're going to make a fixture server. And this is a Pytest fixture that your tests will be able to use, that when your tests say, oh, I want the fixture server, it will actually start a threaded AIO HTTP server in the background and make that available. Now, as soon as you have a fixture server, what you're going to want to do is you're going to want to have remotes that sync from it. And so it's probably the very next thing you'll want to do is define a Pytest fixture that can easily generate you one or more remotes. And this should use that auto cleanup pattern that we saw in the last presentation. And then ultimately, after you have a fixture server running that will serve data to Pulp, and you want to generate remotes that will tell Pulp where to receive and sync from, then you want to use it in your test. So let's look at some of these. Let's go back through steps 2 through 5 so you can actually see what this looks like. So we're going to define a star server root. Oops, that's not the right button. All right. So here, this is what a file fixture root looks like. And this is in, we talked about last time about having a tests, inside of tests, putting a conf test. So you could put this fixture in there. Anything you put in conf test is going to be where you put your Pytest fixtures for your plugin. So these are the ones for Pulp Core. And so this is where we put the fixtures that we're going to use in Pulp Core. And in this case, we're serving these data fixtures that are stored in the Pulp Core repo. So that's why everything lives here. So let's look at the fixture itself. It's really simple. All it does is return a file system path. And you can literally just copy and paste this one into your area and have, instead of file fixtures, you could have the Debian fixtures or the RPM fixtures root. But this is something you do want to copy and paste because you want to name it uniquely. So change the name. But it's important that it lives, like where it lives in your repository is important. So what we're saying is the path to the file that this is stored in. So that would be this. That would be this directory, right? I'm sorry. This file is conftest pulp file, but its parent would be this directory. And then inside of there is the fixtures folder, which is where we're going to store all the fixtures. And so what I'm doing here is I'm forming the path, the full file system path to the root where all the fixtures are stored. And so this is how I recommend declaring it. It's session scoped because you can reuse this for all tests that would want to use this. So you should define the root where your fixtures are stored in your repository. That's step 2. Step 3 is you want to actually make a fixture server. Let's see if I can click on this correctly. Make this a little bigger. So this is the file fixture server, and it uses 2 fixtures itself. These are Pytest fixtures. So it uses file fixtures root. We just looked at that. So that's going to be the full string path to the area where all my data fixtures are stored. And then gen fixture server. This is kind of the magic one that comes from Pulp Smash that does most of the heavy lifting to start the thread and stop the thread and do that stuff. So when we have this new fixture, it's called file fixture server. And when you do this, you're saying, make me a fixture server and start at this root. And we'll talk about other options for the second parameter here, but this is actually the SSL context that the fixture server is going to run with. And in this case, It's just a plain HTTP server, so there isn't an SSL context, so we say it's none. So this is starting a HTTP server that's going to serve data out of where the fixture root is. And then the next thing you'll want to do is you'll want to generate remotes to sync from it. This is a little bit much to just take in if you're reading it for the first time, but it uses that factory pattern that we talked about last time. And right away, when you see, oh, this is the factory pattern, what you can realize is that the fixture, when you go to use this in your test, this file fixture gen remote, what you're getting is a function that's callable. And this is intended to let you call this multiple times. And so this would let me generate, every time I call it, it's going to generate a remote. And that remote, as you can see, is going to take in at the call time a fixture name. So this is actually the name of the directory in the fixtures folder, which you may remember was called basic earlier. So this is that fixtures directory, which could have one or more data fixture folders in here. So basic is the value that I would expect to be passed in here for the name. And then the rest of these are just parameters that I want to pass on to the remote. So in this case, policy is something that's required because I definitely want to know what policy type this remote should be syncing with. And then additional keyword arguments that can get passed on to the remote as well. And so what I do is I use this make URL, and this is the key. The file fixture server that ultimately really comes from Gen Fixture server and Pulp Smash that starts the threaded asynchronous web server has this make URL method on it, which will generate you everything that you need in terms of the host name and the protocol and the port and all those things. And all you have to do is tell it the actual path to the data, the URL within the web server that you want it to access. And so we generate the URL here, and then we say, okay, let's build up the dictionary that we're just going to be used to define my remote with. So it has the URL, it has the policy that was passed in here, and it has a random name that's a UUID. And we're going to use this gen object with cleanup, which we saw last time, which will provide auto cleanup. So this is great because if you make one like this, you can call it to generate remotes. You can generate multiple remotes within one test, and those remotes will automatically get cleaned up. And your fixture server that's threaded will automatically start and automatically stop with your test. So, this is like, boy, this is complicated. Is this really worth it? I think it is because, you really don't need many of these. Like you literally just need one of these, and you can pass in the fixture name for a whole bunch of fixtures. So if you just do this work once, you can use it in pretty much every test you write in the whole repository. So that is how you generate remotes, and then ultimately, this is kind of the fun part, which is where you really use it. So this is the actual test code. It's using these Pytest fixtures, one of which is file fixture gen remote, and because we use that fixture, and that fixture depends on starting an AIO HTTP server fixture. When this is invoked, that server's already been started and is already ready to set up and go. And then every time I call file fixture gen remote, I get a remote that's already fully configured and will provide auto cleanup to it. I then, this particular test then runs basic sync and assert, which does pretty simple stuff. It performs the sync, it monitors the task, and it makes some assertions on what happened. So this is more or less your basic test code. So that's not really the important part of this. We talked about Gen Fixture Server. If you're probably saying, oh my gosh, this thing is really magical, I do just want to unpack what it does just for a minute. It starts a threaded fixture. It starts a threaded AIO HTTP.server locally. It's function scoped, so every test will get its own AIO HTTP.server. And we debated this. Matthias and I kind of talked about this back and forth a little bit, and I believe we agreed that this was better because it's not very much overhead. They auto shut down after the test is completed. And the benefit is that you can make a whole bunch of calls against it and ultimately assert later what calls occurred. And we'll look at this further down in step 5. But this would be more challenging if you tried to instantiate one AIO HTTP server fixture server and serve like a whole bunch of different data fixtures and kind of have it shared, more like a long-lived web server that all your tests share. So it is function scoped, and so each server is started specifically for that test. It shuts down automatically upon test completion. And the fixture itself is actually this data object. And so it starts in the background, but what you get is actually an object that tells you about what it is. It's got a host, it's got a port, it's got some thread. This is not really useful to your test code, but this is necessary for correct operation. It's got an SSL context if you wanted to understand more about that. But these are the really two important things I want to point out. The requests record, this is a request of all the requests that were made against the fixture server, which lets you make assertions on what Pulp has accessed, and we'll see examples of that here in a minute. But also this make URL method here that we saw it use earlier. This is what kind of inspects the SSL context and then builds the protocol handler correctly with the port, etc. So when you get so like we'll go back to this example. So when you get file, well, I don't have direct access to the fixture server here, so this is not the right place to look at. When I actually get when I actually get the file fixture server, like in this part of my code here, when I say, oh, make me the file fixture server, and that uses gen fixture server, the actual value here is this data object that I was just showing off. And you can see that because you can call this make URL here, for example. So one of the goals of this work was to make assertions on the server side, and we could never do that before. And so we saw in the file fixture server that there's this request record object. And these are AIO HTTP.server request objects, which have all sorts of data like the headers used and the request URL and the client header. I guess I mentioned this, but anyways, this request record here is available to then have assertions made on it. So this particular test, for example, is testing headers. So we configure, we say, here's some special header that we want Pulp to include on its downloaders. And so let's make a file remote that will say, oh, let's also include these headers. And then we run the sync, and this actually does the downloading. And then by that point, the request record object has a whole bunch of requests in it, and we can say, okay, let's assert that the path was actually the expected path, and let's assert that in the headers, our header name was present, and let's assert that its value was as it was. And we could never do this before because we could never make assertions in our test code about the server side that Pulp is syncing from. So that's a little bit about how you can make assertions on what happened to your fixture server. If this is seeming magical, I want to demystify it for a little bit. So there's a new Pulp smash setting, which defaults to 127.0.0.1, and that is set here inside of the Pulp smash code. And it's AIO Fixtures origin, and this is the origin, so like the host name or IP address that the fixture server needs to be offered at. So this is important if the Pulp system is on a separate host from the system where your tests are actually running from. So by default, it assumes that they're on the same host. But if you were to configure Pulp Smash with a different value, then you could test a remote system and explain to that system and its remotes how to connect back to your AIO HTTP fixtures. For example, the CI contains this value in its defaults, and you can set this. Your CI templates probably already have this value in it when you redeployed it. But this is what is needed for the system under test in the CI environments. So that's kind of automatically handled for you. And it's used by a Gen Fixture server here. My goal isn't to show, have you understand necessarily each of these parts. My goal is to have you have the slide deck, which has all the links, which can explain how all of this is coming together for you to look at some other time for the most part. But when you generate the Fixture server, its host that it's listening on is taken from this value. And this is the Pulp Smash config. So that's a little bit about how this works, both on local systems and remote systems. So one thing I'm particularly happy about is that the tests that I've written for Pulp Core that got merged with this work support regular HTTP, they support TLS, and they support mutual authentication. That's where clients submit certificate-based authentication. And so there's the HTTP server here. This is just the plain HTTP one because we're saying, let's generate a Fixture server that starts the thread. And none is the SSL context, which is that second parameter. So this is just plain HTTP. But here, let's make another Fixture server, only we'll just name it differently. We'll say SSL. And in this case, we're going to use SSL CTX, which itself is a Pytest fixture. And this Pytest fixture comes from Pulp Smash. And this SSL context is actually generated at runtime using this great project called Trust Me, which is designed to generate real certificates, but at runtime and only for testing purposes. So they actually provide Pytest fixtures to use their project. And so we're just kind of using their stuff, which is super great. So this is an SSL server, file fixture server SSL, and it's an SSL server because I'm saying, just give me an SSL context, which Trust Me provides. And I'm just going to say server. How about you use that one instead? This is the one you probably want to use. I don't think it's productive for all plugins to have all of the server types. I think you probably just want to use the SSL one because SSL is great. And that's all you need to do. Pulp Core, on the other hand, its scope of test responsibility probably needs to make sure that the downloaders can do all the types. And so in Pulp Core, it has all the types. But for your usages, I recommend you make one just like this. Just use SSL context, pass it in here, start your Fixture server, and you probably just need this one. Then there's one in Pulp Core here. That's not the right link. Anyways, there is one that's just not linked correctly. Further down here is, yeah, this is it. This is supposed to be the right link. This uses a different Trust Me fixture, and it configures the server. And this server requires the client to provide certificate-based auth in its connection, in its TLS connection, or it will refuse. And so this is another way that we can assert Pulp's correctness with this type of an architecture. I don't think you need this one at this point. I'm kind of just showing off, but that's something we were able to do by using this type of technology. And it allows Pulp Core to assert like never before. So in here, you'll see tests that say no SSL, and then TLS validation is off, and make sure that TLS validation is on. And let's make sure it defaults to on, and let's do it with cert requirements and where cert authorization is provided. So this is kind of new and unique. All right, my last topic here in our remaining 6 minutes is running tests in parallel on the CI. And I documented this in this discourse post here. And this is more or less all the things that you should do to run things in parallel. And I'm just going to kind of talk over this for a minute, and I believe that's more or less the end of our content. So this change happened in the plugin template. You can see the change here. So when you reapply the plugin template, you actually, if you've reapplied it since 12 days ago, you've already got this capability. What it does is it adds, do I talk about this in here? Yeah, I do talk about it. Anyway, so it lets you run your tests in parallel if those tests are appropriate to run in parallel. So how do you run them in parallel? You mark any tests using the Pytest mark, which is a decorator that you put over the test or the class to say Pytest mark parallel. And here's one used in Pulp core. So this is on the class level, so all the tests underneath it will be run in parallel. And that's how you mark a test as parallel. And you control parallelization with a new template config YAML variable that was added when you refresh the template. This thing is called the parallel test workers, and you'll see it in your template config YAML if you've reapplied. It defaults to 8, which means that it will run 8 tests concurrently. And if you don't want any parallel testing, you can set this to 0 and it will not even run at all. And it'll just do it basically how it did before. And it runs, I guess I should have said this here, but it runs all the tests marked with parallel and then in parallel, and then it runs all tests not marked with parallel linearly, just like it did before. So the test run is kind of broken into 2 parts. And this is nice because even though it defaults to having 8 parallel workers, when Pytest goes to collect your tests and run them, if you haven't enabled any parallel testing, it's just going to collect 0 tests and that part will pass. And then it'll run all the other tests that weren't marked with parallel, a la all the rest of your tests, all the tests, linearly, just like it did before. So this should just kind of gracefully apply without any fuss. These marks, there's a parallel and a serial mark. Right now we really say run parallel test parallelly and then run not parallel. You can see those marks come from Pytest, they come from Pulp Smash, where we say Pulp, Pytest, make sure you know about these marks. And you can see them with Pytest -- markers. You can always see what markers are known. And now if you ran that locally on your project, you'll see parallel and serial. This comes from Pytest -xdist, which is now a dependency of Pulp Smash. So again, you're kind of using it already. And you can mark groups of things to be parallel. So I could say like there's parallel group 1 and parallel group 2, and it's going to schedule the tests within that group to run linearly while running each group in parallel. And so that might be useful to control tests, to control the run order if certain things are not safe to be run, but could be safe, but a whole group could be safe to run with any other group. There are some gotchas. Checking in large binary data, fixture data is not good. So yeah, that's what I'm recommending for now, because that's as far as we've gotten. So there are 2 solutions here. One is to make data fixtures generated at runtime, and the other is to use something like Git LFS, large file storage, to have a side lookup to actually keep it out of your main repo. So give some thought to what you want to do about this if you decide to go this route. What I intend to do is this first one, is to make data fixtures generated at runtime. So here I am recommending that we check in these file fixtures, things like the basic file fixture, but really we should generate them at runtime, because if we generated them at runtime, we wouldn't have to check them in. And also we can make the fixture data checksum unique, which would allow us to significantly parallelize our tests. So that's what I recommend doing. If you want to do that, come talk to me, or let's talk about how to make that happen for your plugin. This is my last slide. My next steps are, like I said, to allow fixture data to be generated dynamically. I'm going to try to demonstrate this with Pulp file. Like I said, it avoids checking in binary large files into the source tree, but it also allows each fixture to be unique as generated at runtime, which should allow us to fully parallelize our tests and no longer require orphan cleanup, which is going to be great. We're very close to achieving this, actually. I'm going to go and port the Pulp core test to using Pytest and AIO-HTTP. This should significantly reduce the amount of test code while also making it versioned, the data fixtures versioned, and cherry pickable, and basically all the benefits that this work claims. We hope to add some proxy tests, which we'll be able to do using proxy.py, which also provides Pytest fixtures that are kind of similar to this. So we should be able to configure proxy.py and its running process with an AIO HTTP server process and have them work together. So if you'd like to work on that, come talk to me. I actually did this in AIO HTTP servers tests already, so we have a pretty great example of how to do it. And we're going to add some additional tests for downloaders in basic auth. And that's the end of my slide and the end of my time. Thank you for your time, and I hope you have a great day.
Thanks very much, Brian. I think there hasn't been any questions so far, Brian. I've had a look around, and I also suspect that people are not watching live. They might be just, say, a few minutes behind, for example. So I think the safest thing might be, if there are any questions, to please post to our community discourse or follow up with us on our Matrix channel. I'll post links to both in the video description. So Brian, thank you very, very much for your time, and we'll see you again soon.
Okay. Perfect. Thank you.
Bye-bye.